Okay, in this section here, it's 6.5. It looks at combinations from a set. This is 6.5 in our Math 830. This is on the formula for combinations is given to us on page 206. And what a combination is it's selecting objects from a set of other objects without actually worrying about what order you pick them in. Now, some calculators have the combination button on them, and some don't. So you can figure these out, these first two examples of combinations, out by using the combination button on your calculator, or you can just work it out by using the factorial button, or you could do it the long way if you have to. So let's just work out some of the applying the formula. So this is 8C4, which means you have a total of 8 objects and you're taking a set of 4 of them out. So that would be 8 factorial over 8 minus 4 factorial times by 4 factorial. So I have a combination button, so I'm going to plug it into mine. So 8 combination 4, and I get 70. If we were to work that out with factorials, you could go 8 factorial, which is 40,320, divided by 4 factorial, 4 factorial. So that's divided by 24 both times. And that gives you the same answer. So no problem. So I'm going to do the same here. For this one, it'd be 12 over 12 minus 5 over 5 factorial. So if you work that one out, 12C5, you get 792. You can do it in any of those ways. So let's look at some actual worded problems of this. A class of 25 students need to select 7 for the game, for 7-Up game. How many different ways are there? Okay, so this would be simple. We have a set of 25 to choose from, and we want to pick 7 of them. So we're doing it in any order. So that means we have 25C7, which equals 25 factorial over 25 minus 7 factorial and 7 factorial out here. So if we work that one out, 25C7, you get 480,700. 480,700. Depending on if you did it the long way or if you have a shortcut method. If you look at my calculator, I have a combination button. It looks like this. It goes NCR, like that. So if you see a button like that, that's what your combination button would look like on your calculator. So let's flip ahead. How many 8-card Kaiser hands can be dealt from a deck of 32? Okay, so if we're going to take 8 cards out of 32, that's pretty simple. That's 32C8. We want to deal out only 8 cards, a set of 8 cards from a deck of 32. So if we plug that in, 32C8, we get equaling 10518,300. I recommend also writing out this part as well. For example, if you write out like this, 32, we know that it's 32 factorial over 32 minus 8 factorial times 8 factorial. If you wrote that on an exam and got this wrong, now if you wrote that on an exam, let's say, and got that right, I would give you your marks because you know what you're doing. Even though we used the calculator, that's fine. That's what they're for. Now, if you wrote that on an exam like that and got it wrong, you get 0 because I don't, know if you made a calculator mistake or if you don't know what you're doing. Now, if you wrote this down and then got that wrong, I could still give you something because you knew what you were supposed to do there. So it's a good recommendation to kind of write that down as well. So let's go to the next one here. A bag contains 7 black, 5 red, 6 yellow, and 3 green marbles. How many ways can you select 4 if there are no green to be drawn? Well, it's kind of like a tricky question. It's a combination question from a set, but you eliminate the green because you can't draw any green, so you just get rid of them. So you don't even consider the green. So you add up the total that you have, 12 and 6 being 18, and leave out the green. So you have 18 possibles, and you want to select how many marbles? Bag containing 7, where did I say? How many ways can you select 4 marbles? So it's 18C4. So if we write that out, that's 18 factorial over 18 minus 4 factorial, and 4 factorial here. So plugging it in, 18C4. 3,060. Kind of had a tongue twister there for a second. Okay, our last example that I have in this area, I believe I have lots of time. How many ways can 3 students be selected from 8 if one must be Jim, say there's Jim's in there, and Aaron is excluded? A bit of a tricky one. One must be Jim. One must be Jim. So that means we have to put Jim in there. So there's only actually 2 other students that we're going to pick from 7. However, it also says, one other thing, it says one must be Jim and Aaron is excluded. So if we exclude Aaron, we're actually picking from 6. We're picking 2 students from 6. So we have to think about that. So that's actually 6C2 actual choices that we have. So if we write that out, that's 6 factorial over 6 minus 2 factorial times 2 factorial. And we plug that in. And it's 15 ways. So whenever there's restrictions, you have to be careful to think about the restriction. When you're excluding somebody, you're actually taking them out of the total. If you must include somebody, you are actually taking them out of the ones that you're choosing as well. Okay, in our next section, we'll be looking at combinations from many sets, and it'll probably be our last, well, it'll be our last tutorial in section 6.